Alrighty, let's see what we got here. Like it's a hard set intersection size at least 2. I'll give myself like maybe 90 minutes for this. You're given a 2D integer rate intervals, or intervals I as start and end. Represents integers from start to end inclusive. This containing set is an array nums, where each interval from intervals has at least 2 integers in nums. A containing set is an array nums, where each interval from intervals has at least 2 integers in nums. Okay. For example, if the intervals are 1 to 3, 3 to 7, 8 to 9, then 1, 2, 4, 7, 8, 9, and 2, 3, 4, 8, 9 are containing sets. Return the minimum possible size of containing set. The minimum possible size. 1, 3, 3, 7, 8, 9. Each interval has at least 2 integers. Let's see. So like 1 and, well, definitely 3 would be part of, Each interval has at least 2 integers in nums. I would have thought 3 would be part of any minimum possible containing set. How'd they get away with not having 3? So couldn't it be 1, 3, 7, 8, 9? 1, 3, 7, 8, 9. Oh, this is not the minimum. This is just an example. Yeah, 3 has to be part of it. Because it overlaps. 1, 3, 3, 7, 8, 9. Yeah, 3. 1, 3, 1, 4, 2, 5, 3, 5. I think 2 looks like it'd be part of it. Maybe no, 3. 3 would actually be part of all 4. And then you probably need something below 3, so like 2. And then that would satisfy that, but not that. So 2, 3, 4, 2, 3, 5. 1, 2, 2, 3. So 2, and then 3. 1, 2, 3. We covered these, and then 4, 5. So each interval has to have at least 2 values in it, right? Intervals length is at least, no, intervals, yeah, I guess they're not the same value, so start and end are different. 3,000 intervals. My first guess was going to be this is like a binary search one where you guess what the minimum possible size is and see if it's possible. So if you guess that the minimum possible size is 10, and then you see that 10 is possible, then you guess something lower. Maybe that might work. But how do you check? The main thing with binary search method would be how would you create the method to check in O of n time that a certain size is possible. So let's say I guessed here that it was possible to do it in 3. What is the value that I choose? I guess the intervals aren't actually ordered, right? I guess the first thing would probably be ordering the intervals. But then the intervals can overlap. There's nothing preventing it from overlapping. I 2, 3, 2, 4. What's the greedy approach here? Greedy approach would be finding the biggest common value between intervals, biggest common earlier value. Greedy approach might be to maybe use the biggest two values in an interval, but then that wouldn't work if it was something like 1, 10, and then 2, 4, right? The biggest two values here would be 9, 10, but then that wouldn't even hit any part of the interval 2, 4. So definitely wouldn't be fast enough to go through every single value of an interval, for every possible interval to see if it works. I wonder if it makes 1, 10, 2, 4, 1, 4, 2, 10. I wonder if there's any relation between the approaches here. Yes, you can't just chop up interval sets, because even if something fits, can you chop up interval sets? Splice it. So 1, 10, and then like 2, 4. So ignore that this is probably like not necessarily 10 dashes, but close to that. So let's say our intervals look like that spatially. So we're picking the columns. A number would fall into a column of this. So if I pick 3, then any interval that has something in the 3, then I probably pick 4, right? So that's like 1, currently like 1, 10, 2, 4, like 3, 5, 3, 6, currently 3, 7, 3, 4, 5, 6, 7. So if it was 1, 4, 2, 10, that makes sense. 1, 4, 2, 10 versus, no, almost certainly doesn't make sense. We rearrange the endings. That limits the possibilities. 1, 1, 2. doesn't necessarily rearrange the number of spots. 1, 2, 2, 3 versus 1, 3. Yeah, it doesn't make sense to have a 2, 2. No, 1, 2, 3, 4 versus 1, 4, 4, 7 versus 1, 7, 4, 4. Yeah, this is just bad train of thought. Or ignoring the fact that I could, in theory, rearrange the ends of the intervals for some reason. I'm picking the columns. Picking the columns. Could, in theory, for each spot, determine how many things hit that spot. For each column, how many intervals would overlap, would have that value within it. Then there's definitely going to be cases where it's not optimal to go for the column with the most overlap. It's just definitely not going to be that. For each interval, there has to be at least 2 things. Each interval, there has to be at least 2 things. So if the interval has only 2 items, then it has to use those 2 items. I wonder if I can start with that understanding. There has to be some values that are non-negotiable. Does that even make it simpler at all? So if there was an interval that was like 4, 5, 4 and 5 have to be part of the minimum containing set. And then you'd have to remove 4 and 5 from intervals that might include it. And then you'd have to guess from there. Guess from there. Wonder if this is. Wonder if this is dynamic programming. $3,000. I'm missing some parameters. If I want to use dynamic programming here, like what is your thing that you're dynamically programming? The number of values in a set is part of the state. The number of values in the set, maybe the values of the set would just be too big. values in this set. The size is also too big. Yeah. Can't just iterate 10 to the 8th. It's 100 million. 10 to the 9th is a billion. The intervals has 2 values. Those values must be in the containing set. guess the other kind of truism would be a value that is overlapped, that overlaps multiple containing multiple intervals is preferable than an exclusionary value. It only is in one interval. Yes, if you think about exclusionary values, then it's arbitrary. Exclusionary values can be arbitrarily picked. So if like it's 110 and 2, if the thing was like 110 and 2030, they're all exclusionary, there's no overlap, so you pick any 2 in the 110, any 2 in the 2030. So how to maximize your usage of overlapping? The question is best choice of values that are overlapping, right? It's choice of values that are overlapping. Each overlapping value doesn't necessarily reduce the maximum by 1, right? Say, in theory, worst case with duplicates maybe would be like 2 times the number of intervals, right? Every interval every interval is exclusionary or non-overlapping. Or or just very bad picks, or not very bad. It's just like worst possible picks of values, such that you avoid any overlaps. So those can't be worse than 2 times intervals. Then every value that you pick doesn't necessarily, every overlapping value that you pick doesn't necessarily reduce that worst case size by the number of overlaps because in theory sometimes you already picked a value that you already picked two overlapping values and the set is already done, but then there might be another overlapping value in the set, and picking that doesn't necessarily reduce it. Hmm. All's boiled down to optimal overlaps. Let's go ahead and map out this. 1, 3. I wonder if I should use something besides dashes. That's even worse. Maybe this better than dashes, to be honest. Okay, 3. Oh, yeah, that's. Maybe I should be using spaces. So 3 is going to be, 4 is going to be 1 to 4, 2 to 5, 3, 4, 5, 3 to 5. So choices here were like 2, 3, and 3, 4 were possibilities. No, actually it's 3, 4, 5. Had to be 2 here. Had to be 2, 3, or 3, 4. Overlap, overlap. So 1 hits 2. Everything here is overlapping. Every value has some sort of overlap. And then we use the highest overlap. Three was the highest overlap. But it was possible that 3 wasn't part of the solution, to be honest. Pretty sure. Like if what was it? If it looked like this, no, 3 is definitely part of this overlap. Can I construct an example where the highest, the value with the highest overlap isn't part of the optimal set? Optimal set? Pretty sure. if it was something like yeah, it'd be something like that. 3 is the highest thing, but in theory you do want to, well, doesn't this play out easily? One, two, three. Okay, I mean like something like this, I guess. 3 has the highest overlap, then does this work? 5. Okay, yeah, 3 has the highest overlap, but then your answer should be 1, 2, 4, 5. I mean, it's kind of a trivial, weird case, which can be solved or ignored if you will rule out having to deal with intervals that only have 2 values or guaranteed to have those values in the set. So at that point you just would eliminate, well, at that point you pretty much eliminate everything because everything has values that are guaranteed to be part of it. Okay, maybe this is part A. Must include is going to be a set. Or I'll just call this must. Need, required, base. I guess base might be a fine word. For every intervals. For every, I guess, A, B in intervals. If A plus 1 equals B, base dot add A, base dot add B. Okay. 8, 9 was part of the base here. There's nothing here. Everything was part of the base here. Is that the right answer? Come on, 2 through 4. Huh. So ignoring the base stuff. Is that ignorable? Is that ignorable? Um, 10 to the 8th. That's such a big number. I wonder if you can just I wonder if there's certain numbers that are relevant numbers, to be honest. Like, out of all the possible things, maybe it's something where the minimum possible containing set are values that are one of the n values in any interval. Like there's no possible, or you can construct the minimum possible set based on just the values that you have for the ends of the intervals, start and ends of the intervals, and ignore every value that's between those two. Is there ever a case where that's not true? So I'm going to guess min possible set can be constructed using only values from values that are start end of some interval. So can ignore values that are between intervals. That would make it a lot easier. I'd maybe simplify it to at most 6,000 values. So the next thing is can a test case be made where the above is false? See this test case. Fuck. Well, 2. So 2, 3, 4, 5, 8, 9. The 2 is just arbitrary. The 2 could have been a 1. I guess that's kind of an exclusionary value, non-overlapping value. 3. The 4 could have been a 7. So that was another kind of non-overlapping value. 8 and 9 are definitely just whatever. So this 2 could have been a 1. Or actually the 2 is already part of it. 2, 3, 4. Yeah, maybe that's something to consider. Because anything that's in the middle, the reason why you'd pick in the middle is because somehow there's some other interval that actually has that as kind of a magic number to consider, because it's part of the end or beginning, and if it's kind of the small set, then if it's not something smaller, then there's some other interval between them that's kind of magic. Interesting. Let's go ahead and do all values as a set. I guess that would be all values dot all values add a. I wonder if I can actually do on set add multiple items. Can I just add it as a comma separated? Update is using a list. Oh, A and B are actually values. Unpack it. Leave it alone. Let's go ahead and say all values is converted to a list. And then sort. Two, 3, 7, 8, 9. Yep. So 6,000 isn't that bad, to be honest. At most 6,000 values. So I can go through all values and determine for each value whether I include it or not include it. Whether I include it or not include it. Oh. Each. Every interval. If I go through every interval, the interval has a base value in it, value that's guaranteed. Like let's say it's 1, 3. Let's say it's 1, 5, 5, 6. 1, 5, 5, 6. Then 5 and 6 are guaranteed to be part of it. 5 is going to be getting, so 1 and 5. So here, this would mean that 5 is guaranteed to be part of it. If the two guaranteed values are strictly inclusive or strictly within the outer interval, then that interval can get dropped. So I guess that might be the first step, to kind of so this means that 1, 5 can be dropped since 4, 5 are base values. And then if it was something that wasn't inclusive, but only overlapping in one thing, then some value, either 1 or some other value in the range of 1 to 4 must be picked, right? So like if this was 1, 5, 5, 6, and say it was 1, 5, 2, 7, 5, 6. In theory, the 2 would be picked, or the 2 would be the most optimal thing. So there can be 1 or some value between 1 and 5. That's also part of the set, part of the all values set. One five five six two seven 15275 6. 25 actually 27 is actually already inclusive of 56. So 27 actually we dropped, at which point 15 would only have 1. So it doesn't matter if it uses 1 or 2. It makes sense to go through every interval and remove the base. It's not like that would work. How would it work? Go through every interval, remove the base. You're left with 1. Left with 1. 5, 6. What do you remove? You remove 2. I guess you remove 2 and 7. Interesting. Remove 2 and 7. So you're left with like 1 empty, empty. So you have to pick a 1. Well, no, that's not true. Well, yeah. 1, 5, 5, 6. How would it play out for the optimal thing? So let's say it was 10, 15, 16. I guess this would be like 112. So 15, 16 are part of the base, so you remove those. So it's 10's left, 112's left. In theory, you'd either pick 10 or 12. There's like 11, 12 for the base. It's 10. So if you remove all base values, you're left with 112, 10, and blank. Does it matter? Does it matter if you choose the 10? I have to choose the 10 or the 12. I have to choose the 10 or the 12. Or in theory you could choose 11, but that's to be ignored. Huh. I think maybe this would be easier if I just reconsidered this in terms of reordering the numbers. right? Because the numbers, I can exchange the numbers to be the rank of the number rather than the number itself. It probably doesn't necessarily need to be that for the solution, but for ease of thought, exchange all numbers to the rank of number. So the rank of the number would be like 1, 12 is 3, 10 is 2, 4, and then I have a 4, 5. One, 3, 2, 4, 4, 5. So there's gonna be at most 6,000 ranks. If all the numbers were, if all 3,000 intervals had unique numbers. 6,000 ranks. The question is, what's the minimum set of ranks? Minimum set of ranks. 1, 3, 2, 4, 4, 5. So 4, 5 is included. If I remove those ranks, 1, 3, 2, empty, 2 blank. 2 blank means that anything above rank 2 should be fine. Anything? I guess that's not true. It has to be at most 4. Or 2. I wonder. If I remove a rank, can I somehow exchange it with a lower rank? So 2, 4 becomes a 2, 3. That just adds more values though. And then the 2, 3, there's only one thing that you need in there rather than 2. I guess, no, that's not true. I guess if I'm replacing it with a rank, then that just means I'm replacing it with a lower value that actually does exist. So all ranks exist between 1 and the max rank. So replacing a rank value with a higher or lower one is fine. So this becomes like 1, 3. I'll say this is like 2, 3, indicating that there's only one thing that I need from there. So I pick either 2 or 3. That makes sense to pick 3. So if you remove only one value from an interval, from a rank interval, you replace it with the rank that would be appropriate. So 2, 3. So if this was like this is like 2, 5 somehow, then let's replace it become 2, 4. I don't know if that makes any benefit there. This 2, 4 still implies that 3 could work, rather than picking a 2 or 3, or picking a 2 or 4. Rank, 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 rank. This is a rank problem. Actually means that means it's bad, right? Rank. Or is there a different spelling of it? Rank adjective. Offensive. It's a rank failure. Anyways, 1, 2, 2, 3, 2, 4, 4, 5. Do. 1, 3. So if I do 1, 3, so do 1, 3. One. So for every. Okay. I'll work on actual non-trivial examples maybe. So it's 1, 5, 2, 2, 6, 3, 10. I guess I need every number in here. 1, 5, 2, 6, 3, 3, 7, 4, 8. Okay. No base numbers. If there's no base numbers, what do I do? What would I do? One, 5. One, 5. So the numbers in consideration there would be 1, 2, 3, 4, 5. Probably not the 1. Although I don't think I can include that. Can I not include that? This is 1516. Guess the 1 could be included. 1, 5. Can I use a stack? Can I use some sort of dynamic programming? Indices. It's too big to use backtracking for sure. Can't just guess and then see if it works and then go backwards if it doesn't. 1, 5. Can't be greedy, can't just assume to use 1 and 5 or 5 and 1. Can't be greedy. Binary search. Back 1526. Stack. Stack. 1526374. Interesting. I feel like a stack is very similar to greedy, in that there should be some test cases where the greedy approach of a stack wouldn't work. Stack here would be something like I put 1, 5 in the stack, I put 2, 6 in the stack because there exists something that overlaps between 1, 5 and 2, 6. I put 3, 7 on the stack because maybe it's going to be 2 actually, because 1, 5 and 3, 7 have some overlap. Maybe it requires 2 overlaps. 1, 5, 2, 6, 3, 7, 4, 5, they all have 2 overlaps. So therefore 2 is the minimum, which is 4, 5. If I do that, that might actually cover the base case as well with the guaranteed intervals. So you put intervals in the stack, or you put intervals on the queue if the intervals in the queue, if there is 2 overlap between that interval and the front of the queue, there's at least 2 values of overlap, which means that there's some sort of values that can pick that would work, and then what if it doesn't? So what if it was something like 1, 5 and 5, 2, 6, 3, 4. Now that's still gonna have it. Alright, I think I need to do the remapping in order for this to play out. So every value becomes rank. Dictionary is going to be rank dictionary will be dictionary, then for every index in range of n, where n is the number, let's say v, where v is the number of values. We're going to go ahead and do rank dictionary. This value is equal to this index, which is the rank. And then I would need to convert the intervals. So, say rank intervals, rankfuls, no, rank the R intervals. Rank intervals is a list for every, is this going to be sorted? I think sorted, yeah. For every A, B, and intervals. Then rank intervals, append tuple that is the rank dictionary for this value, the rank dictionary for the second value. Well, since we already have, we can go to the first example, I guess. Rank dictionary key error 1. Oh, what's going on here? Oh, whoops, I'm using the wrong thing. Rank dictionary, the value itself is all values at this index. Alright, so this becomes 0, 1, 1, 2, 3, 4. Guess the base, you convert the base stuff into base. Actually, yeah, I need to do this afterwards. Should I do it afterwards or before? I guess, yeah, I don't need the base stuff. Do I? Kind of still do need the base stuff. All values become a list. Sort it. Base stuff, base stuff. Intervals A, comma B in intervals. Rank dictionary. I guess maybe I can say if rank, let's say rank A, rank B. And then if rank A is +1 equals rank B, then the base ranks would be inclusive of this. Okay. I think we can print out the base ranks here. And 2, 4. t 1, 2, 3, 4. Okay, so what was I thinking here? So I have a q. If the front of the queue, I need to somehow ignore base ranks in there. Maybe the base rank should actually be a array of booleans. Huh. Because how else would I actually? No, actually, I don't need the base ranks. So 1526. This is something like 1523. Then 1523. If the interval that I'm dealing with is strictly within there is strictly two values, then this thing definitely just pops. This thing clears from the front of the queue because I know that I'm going to be using these two values guaranteed. I know I'm going to be using these two values guaranteed. So it doesn't matter what I pick here. But if it's not, let's say it's 2, 4, then if there's enough overlap, there's like at least 2 overlaps, then I have to keep the 1, 5. Well, if it's strictly inclusive, then I should remove it, right? Like, because if I pick two values within 2, 4, then it's going to be within 2, 1, 5. So if it's strictly inclusive, regardless of the size, I should clear the front of the queue. So this is queue system. If front of queue is strictly inclusive of next interval pop front. So if it's not a trivial case, so let's say it was like 2, 2, 7, then I can't do that. Or if it was something like 5, 7, which would appear later on, because it would have been with ranks 1, 5, 2, 7. If it's not, then what? So let's say it's 2, 7, 3, 4. 3, 4 here would just pop this and pop this. So 3, 4 would just clear the front queue here. So let's say it doesn't somehow pop. So let's say it's like 3, 5. Well, 3, 5 is strictly inclusive of 1, 5. 3, 3, 9. So 1, 5, 2, 7, 3, 9, 6, 8. So there's still at least 2 values of overlap between must have 2 values of overlap between next interval and front of Q in order to add to Q. Q contains all intervals that have at least 2 overlaps, but uncertainty as to what. If there's a and non-trivial overlapping. I guess that's maybe synonymous. Because if there was a trivial overlap that was strictly inclusive of another, then you go with it. One 527. Yes, in theory. I wonder if it was possible for it to be like 3, 6 is in theory inclusive within 2, 7. But then it's not strictly inclusive within 1, 5. So maybe you, or how to compare that. One 52736. Could maybe compare the next interval with the back end of the Q. Back end of the Q could be that 3536. Maybe I should be decreasing sort on the second value rather than increasing sort on the first value, decreasing sort on the second value if there is a tie. Because I probably would like to do 3, 6 and then 3, 5. 1, 2, 1, 3, 1, 3, 1, 2, 1, 3, 1, 2, pops the 1, 3. 1, 3, 1, 2, 1, 2, 1, 3. 1, 2, 1, 3 is strictly more permissive. Yes. 3, 6, 2, 7. So what if it's 1, 5, 2, 6, 3, 6? 1, 5, 2, 6, 3, 6. The front is gonna be higher. The back side. Yeah, I think I need to backward sort the second value, the end value of the interval. Because 3, 6 should pop the 2, 6. And then it doesn't pop the 1, 5 because the second value is still bigger than the second value here. Yeah. Huh. Okay, that's going to be, so it needs to pop the, so 1, 5 pops. Is that true? 1, 5, 2, 7. The 2, 7 pops, and then the 1, 5 pops, and then the 1, 5 stays. Doesn't want that. This 3, 6 is strictly inclusive within 2, 7. Included within 2, 7. Or if it was something like 4, 5 here, right? 4, 5 is going to be just comparing the biggest values. The 7 is bigger than the 5, so it requires that this thing's to be included. Then the 4, 5 popped off the 1, 5 as well. And you're left with a 4, 5 at the front. And at that point, the next would have to be 4, and would have to be 5 and something. Because 4 and something would be in front of the 4, 5. Oh. So I can't do sort normal here. It has to be something like all intervals sort is fine. Actually, interval sort is not fine. I think it has to be interval sort t equals and x, where x is tuple that is 0 and negative of the first index value. Alright, and we'll do a test case to make sure this works. I guess I can just do ranks pretty much. So 1, 5, 2, 7, 4, 4, 7, 4, 4, 5, 4, 7, 4, 7, and 3. I guess I'm missing a 6, so it's going to have to create a 6. 0, 1, 2, 3 is your start. 4, 5. Okay, that looks fine. Is that? No, that's not right. Maybe that is right. So 6 should be equivalent to the 5. 0, 0, 1, 2. Running the base. Rank intervals. Intervals. Alright, 1 map to 0, 2 map to 1, 3 map to 2, 4 map to, oh, 8 was the 6. Okay, yeah. So, yeah, this looks fine. 0, 1, 0, 4, 1, 5, 2, 6, 3, 5, 3, 4. So the 3, 4 would actually pop the 3, 5, pop the 2, 6, it pop the 1, 5, because everything there is is strictly inclusive within those intervals. And then it would actually pop the 0, 4 as well. So 3, 4 was equivalent to picking values that were 4, 5. 4, 5 is included. Yeah, 4, 5. So it pops everything that pops all values, all intervals that are including it, which works if it's a base interval. That's required. The last thing was not, so that's kind of the trivial case. If I ignore the 3, 4, ignore the 3, 4, let's say it was just the first. Let's say it was just that. So I end the run. Everything here has 2 values that are included 2. Therefore the answer is 2. Okay, so then the other case would be if there's not 2 overlaps. So there's no overlap, but there's 1 overlap. For some reason I feel like I should be also popping not just the back side, but the front side. Pop the back side if it's like ambiguity. If there's some portion of the latest interval doesn't overlap with the previous interval. That makes sense. I pop the back side for ambiguity. And I pop the front side. So everything here currently has 2 things that are overlapping. So I see. I think I either clear the whole queue if there's no overlap between the latest interval and the previous intervals. Because all the previous intervals are going to pick 2 values that overlap whatever 2. And if there's 1 overlap, then so if there's no overlap, there's either going to be no overlap, 2 overlaps, this interval has 1 overlap thing. So something like this. to be non-overlapping for some stuff here. Has to be non-overlapping. Or there has to be something like that's not overlapping. So that means that so if there is no overlap between the latest and the latest and the last in the queue, clear the queue. Clear the queue. There's no overlap. There's no overlap. Just pick any two values that it's going to be shared with the queue. So therefore, there has to be some overlap I'm concerned with. And there has to be one overlap. Because if there's two overlaps, then that means that those two values will be used, or there's two overlaps. There's two overlaps, then I should be clearing the queue in that case, right? Because then I keep popping each thing. This was somehow inclusive with everything. Yeah, so pop, pop, pop for inclusive interval first. So then that just leaves the case of one overlap between the latest and the latest, or the next interval, the last interval here, one overlap. Because if there's more, then I pop. If it was 4, 6, then I would pop the 2, 6. Oh. Actually, what happens here? 2, 6 is strictly inclusive. Strictly bigger than 4, 6, so so that doesn't quite work. So I would have to pop 2, 6 here. I realize that let's say this is actually, yeah, let's say it's 2, 6 comes 4, 6. What's that mean though? Therefore 1, 5, if this was 2, 6, that means that I'm more concerned with the 4, 6. Because some things within the 4, 6 has to be used. So 2 things within the 4, 6 have to be used. At that point, I don't guarantee that the front of the queue and the back of the queue are aligned to always include 2 values. So I would remove from the front of the queue anything that doesn't have 2 values shared. and anything that doesn't have two values shared, removed from the front, is going to add 1 to the answer because they must all share at least two values. So the queue includes everything that has two values shared. And when I remove from the front, I remove everything that doesn't have two values shared. When I remove from the front, if it doesn't have any shared value, the backside, then I would need to, if the front doesn't have any shared values with the backside, then I remove and add 2 to the answer. If the front only has one thing shared with the backside, then I remove and add 1 to the answer. Might work. Maybe. No. Front and the back. If nothing in common, then I should clear out the whole queue now. Doesn't really matter at that point. Maybe that should be the first step, to be honest. If the front and the back doesn't have anything in common, then I clear the queue. Therefore, the front and the back should have something in common. And then opt for inclusive interval. This interval would only occur, right? So if it's 0, 0, 4, 1, 5, 4, 5, say it was something 0, 3, 1, 5, 4, 5, something like that. 0, 3, let's clear the whole queue there. Yeah, because the two things here just doesn't matter. I could be using a 1, 2. Doesn't really matter that 1, 5 is already inclusive of 1, 5 because it's already working with the 0, 3 when you clear it. Find the queue and the next interval has no common, clear the queue, add to the answer. Opt for inclusive interval. So 4, 5 pops. So if there wasn't anything cleared here, so there is some interval that's common between 1, 5, and 4, 5. Then I pop the 1, 5 because 4, 5 is strictly harder requirement. So anything with 4, 5 works would work with 1, 5. So let's say the next thing was like, so if it's like 7, 10 here, then 4, 5 would pop because there's nothing in common, and that would require 2. And if it was, say, 5, 10, then there's going to be something in common. So 5, 10 would mean that 10 would mean that only one thing in common. Pop 4, 5, add 1. Then I pop 4, 5, add 1. Because if there's only one thing in common, then no. I guess I leave it, right? Leave it. 4, 5. No. There's only one thing in common between the front and the latest. Then I would need to pop. Say it was 4. Let's say it was something like 4, 7. I guess 5, 7 is strictly inclusive. Yeah, so let's say 4, 7, 5, 15. Can't be 6, 6, 13 because that pops to 5, 15. Actually, so when I pop for inclusive interval, that could end up being that the front and back don't have anything in common after that. Should be popping for inclusive interval first. Pop for inclusive interval. And the front and the back don't have anything in common. Add 2. And clear the queue. Add 2 to the answer. Yeah. Feels right. Okay. So there, that leaves the case where there is some commonality, and the commonality is exactly 1. That's the only case that's remaining. 4, 5, 5, 10, something like that. So I think at that point you have to remove the top. If single value in common, clear front and answer plus 1. It's 4, 5. It has to pick 4, and therefore the 5. 4, 5 has to pick 4. Yeah. It's 2 values between 5 and 10. It has to pick the 4 and the 5. It's the only way that you clear it. There's only one value. Or let's say it's like 4, well, it's 4, 6, then you don't clear the top at all because there's 2 things in common. Actually, at this point, there could be 2 things in common. So if there's 2 things in common, then you just leave it as is. there's two things in common, leave it as is. Like, I guess it had to be 5, 6, or it has to be something 5, 5, 10, 5, 9, 5, 6. 5, 6 would clear. 5, 6 would clear everything because it's inclusive. Five, 5, 10. What does this mean? Can't have a queue. Can't have both in the queue because then we don't have two things in common with everything in the queue. But there's only one thing in common. There's only one thing in common. Just remove this thing and add 1. The 5 is required at that point. 5 is required at that point. This is kind of a stupid example. 3, 5, 5, 10. So there's one thing common. Clear and add 1 to the answer. That requires me picking 5 as the value it's shared. So 3, 5, 10. Three, 5, 5, 10. Does this ever occur? This 4 has to be somewhere. These are ranks, so 3, 5, 5, 10. 4 had to occur somewhere here. So either the 4 was something that was like that was strictly inclusive, that was popped maybe. It was 4, 5, 4, 5. No, 4, 5 doesn't come before 3, 5. So it was something like maybe 3. Could have been 3, 4. How would a 4 have worked here? Like maybe there was a 4 here in this. 1, 4, 3, 5. And then 1, 4, 3, 5. How would that have worked? I'm not sure if it's feasible to get into this situation. 3, 5, 5, 10. And this might have been required to be a 4 here. 3, 5, 5, 10. So like 4, 5, and this is kind of a trivial case. 4, 5, this has to be for the answer. If I do check that, so 3, 5. There's one overlap. Okay, so let's say it was 1, 3, this was a 2-3, then 2-3 is strictly inclusive of 1-3, included with 1-3. So 2-3, 1-3, 2-4, and then 4-5 here. Yeah, that's fine. Then 4-5 here would mean that I would clear off these two because the 1-3 is not included with 1-4-5. The 1-3 is not included with 1-4-5. So then I pick two values between 1-3 that share with 2-4. And then the answer plus 2. Okay. So that case just doesn't work. So that wouldn't be. So if I add 3-5 here, so add 3-5, 3-5 shares exactly one value with the 1-3. So 3-5 doesn't pop 2-4, shares one value with the 1-3. What's the play? Say that 3 is required somehow. How would I track? Could I say make 3-5 into 4-5? I think. Could I make 3-5 into 4-5? Yeah. Have to pick 3. Have to pick 3. Or 3 seems to be like an optimal choice. Three seems to be an optimal choice. Hmm. Three seems optimal. One, 3, 2, 4. Hmm. Wonder. Three. 3. So two of the values. 1, 3, 2, 4. Three. 1, 324. Alright, I think this is time for me to call a night. I think it's been close to 2 hours.